Well, hi, good morning. Thank you once again for joining me in my shop for another step along the way with this radio. And what are we going to do? Hey, today the weather's changing here. It's going from kind of cool, nice weather to hot and humid, sunny weather. Big change happening for the next few days anyway. So the return of summer is coming here. Now that the weather report is done, what have I got left to do in this radio? And what am I going to do today? And how am I going to make this interesting? And how can I set things up so I can learn something here? So there's 1, 2, 3, 4 more paper capacitors, all of which would probably, well, it certainly wouldn't hurt the radio to change them out. We got a big one here that's soldered to the chassis. That's pretty curious. And then we've got 3 small ones. One of them here is carrying the audio signal from the volume control through to this pin. Now this pin on this tube is not actually used. This is a spare connection point. So where exactly the audio is heading, I don't know offhand. That doesn't matter right now. I think what might be interesting is to trace out the RF past the last IF transformer where the detector diodes are. And the RF is supposed to be quenched at that point, and there shouldn't be any left. But there could be. It would be interesting to kind of trace it along through the radio a bit. I do have a signal tracer that's good for that. I got a couple of them. I got 3 of them actually, for crying out loud. So we can use this signal tracer. It can be tuned to a particular frequency. That would be the IF frequency. And we can trace it where it comes out of the IF and works its way along to the volume control, and then onwards beyond the volume control. There should only be audio here, but there could still be some RF. Excuse me. I don't really know. I want to find out. Curious minds want to find out. Okay, I don't even know if the method would work, but we're going to give it a try and see what happens. Often when I'm doing these things, I discover something unintentional that is worth knowing anyway. So let's go wander around the woods a bit and see what we can find. But first, my first priority is I got to make a cup of coffee. That's my first priority here. Okay, just about ready to get going. I've got the signal generator over here working around 1 million, a little above 1 million. We'll tune that in. Signal generator is feeding this loop, which is just sitting near the antenna of the radio. Let's switch on the radio. Now, just before I do that, what are all these meters you can see in this in this camera shot? Oh my gosh, all kinds of them here. So vacuum tube voltmeter, won't be using it. That's an audio output meter. Won't be using that right now. Okay, so this, and this are all of interest for what I'm doing. They're all kind of showing the power level or voltage level at some point. This one is showing the voltage in the outlets in my house. So, that's just plugged into an outlet, and it's always showing the voltage. Even when I leave the shop, it's still showing. How accurate is this? Not very accurate. So that's 115, that's 120, so this is 117.5 it is claiming. So this meter, which can be varied with this control, is showing the output from this device, actually the output on this right here. I normally don't do much with this. I kind of just leave it in the circuit, and right now it's jacked up above the regular line voltage, so it's putting out close to 130 volts or so. That's because that voltage will be diminished by these light bulbs, and we'll end up with 115 or so at the radio. This meter, which is a little hard to see down there, one of my buddies built this for me. So it has a Zener diode in it, cutting off a big chunk of the voltage. So the scale starts at 100 here, it doesn't start at 0. It's from 100 to 140. Again, this is not a terribly accurate meter, but this meter is showing what is right on the plug that the outlet box here that I'm plugging the radio into. So in fact, this plug here is going straight to this meter. Again, not very accurate. And I have this device here, which is quite accurate, which will tell me not only the voltage, but it will tell me the current flow, the amount of power. It's a very interesting little device. But I have all these meters. Now the last one, the weirdest one, is this one. This one is a percentage meter, and it's telling the percentage of power which is getting, which is being derived from this box. Okay, well, I'm not going to explain the box. Okay, the box here has two switches on it. It has a master power switch, just on and off, and then it has a selector switch. If I push it with this off, if I push this down, power is routed through these lights on its way to the work, on its way to this outlet here. If I flip it up, the lights are no longer in the circuit, and the radio, or whatever I'm working on that's plugged into this, is basically plugged into this. Now this is an isolation transformer, and behind it is another isolation transformer for reasons I couldn't even explain. I've got two in series for no good reason really, but there they are. So that's what's going on in here. When I hit the power, when I flip that down, this meter will jump up. Well, it'll only jump up if the voltage here is above 100. Otherwise it's going to sit in right on the zero there. Why do I have all these meters? I don't know. You tell me. Okay, so we're going to start the radio now. This time, so watch for this meter to jump up. This one should jump up too. There we go. He tells the truth. So this one's almost up all the way, which means almost 100% of the supply voltage is making it through these bulbs to the work. This says 120 volts. I'm sure it's not correct. It's 112. Now here comes the radio. A little low because I fiddled with this earlier. I'll just turn that up a little bit. 112. Well, it doesn't really matter. 112 is fine. 112 is good. So we can hear the radio now. Okay, there's that annoying interference I hear all the time. And now we're going to want to pick up the signal from the signal generator, which I've got set quite high power-wise. So this should really be easily heard. The radio is currently tuned to around 9. Ooh, we better tune it up because my signal is, let's go above. So I'm tuned right around 1 million. Now what I'm looking for is a nice clear tone, but I've got some swooshy thing going on in there. It's probably just because of where I've tuned the radio. So we'll try a different spot. That's a little better. So with the radio tuned off, or the signal generator tuned off, you hear that typical hissing roar. Why does it get quieter when I tune in the station? I used to think, well, the station is knocking the noise out, but that's not at all what's going on. What's going on is the radio's own automatic volume control is being activated by the strong signal coming from here, and it's just weakening the whole, or another hand, weakening the whole radio's receptive strength, and the noise is going down with it. So as a strong signal comes in, the radio gets quiet. That's what's going on. Okay, we're ready to start here, I think. Just a little bit. Just a little more. That's got to be tuned in there. Now the objective here is to listen to the signal passing through the radio and follow it as it leaves the second IF transformer, gets detected, and see how long we can follow it. And we're following the RF coming from the intermediate frequency stage. So we're going to tune this guy. First we got to set it to RF. And we want to tune it to 455. We want to be on band A, somewhere around here. Okay, let's see what we do. Okay, so a good place to start would be input to the volume control. I can see a wire come out of the hole in the chassis here where the wire's coming up from the IF transformer. It's connecting to that terminal, and then a black wire is continuing over to the input side of the volume control. Let's go right here. We don't need to listen to this at all. We really just want to listen to this guy. What do you hear? Now, it may not be tuned. Oh, just getting close. Okay, hand on the volume control. So this device has two kind of level controls. One is the volume control, and the other one is controlling the amplification internal in the device. It has a magic eye here. It's quite a distance for you to see it. It's open at the bottom. When I hit the signal, the eye closes a bit. You can kind of see something going on in the eye here. If it closes too far, it's kind of overloading this, and that's what was happening there. So I'm going to cut back using the attenuator here until I get the eye just closing. Okay, so I've got it set now so the eye is just closing. Now anywhere I meet that same signal strength, the eye will be just closing again. So I get some kind of a relative impression now. So we're going to stop and look at the schematic at this point and sort of just plan out our route here before I get too far into it. Okay, let's go to the schematic here. Okay, so what we were just listening to, we were listening right here on this piece of wire, right here. See, it's going up to the top of the volume control, or the input side of the volume control. And we see a series of capacitors and a 5 megohm resistor up here. And there's the grid cap. So the audio signal, guessing, I'm not sure, there's a very small capacitor here. Can audio pass through there? Shouldn't. We don't want audio passing through there because we want to be able to turn the volume down to nothing by moving this over to here. So we can assume no audio through here, but it's here for a reason, so it must be passing the RF this way. This is a large capacitor comparatively speaking, so the RF, anything that gets through here is going to travel through here. It's going to end up on the grid of this tube. I'm a little surprised. Yeah, 5 megohm resistor, very high impedance circuit through here. This small capacitor may carry some audio. It shouldn't. Who would want that? Well, so we've got to this point and we can clearly hear RF. Well, we can go on the other side of this big resistor, see what we hear there, and we could go on the volume control, and we can vary the volume control up and down, but the sound's going to come out of the speaker while I do that, unless I pull this tube out, which I can't do, because the tubes are all in series, so I can't disable it that way. That's getting too far into it anyway. Okay, we'll go on this side of the resistor, and we'll listen to what's coming out of the volume control, and see if we still hear this tone, or if it's beginning to go away. Okay, back to the radio. Volume here. Other side of the huge resistor. Nothing. this up. Okay, the sensitivity is way up now from where it was, up by a factor of 100. Look at that, you can hear it airborne, but not in contact. Good. Okay. That's kind of what I would expect. Let's go back here and double check. Calibration. Good. Now, let's come up to the volume control. We come out of the volume control into this capacitor here. So let me just see if I can tip the camera just a little bit closer here. I'm going to get on the slider or the variable part of the volume control. Now the difficulty here is it's going to come out of this speaker and it's going to come out of that speaker at the same time. So now I'm listening with 2 ears in stereo, 1.5 ears really. So what we're hearing coming out of here is the audio. What we're trying to hear out of the other is the RF. Oh, this is going to be a little tricky here. Trying to get a good solid grip there so I can fiddle with these controls. Okay, so we hear the tone here now. Just getting close to the volume control. Better watch out. There's 120 volts right on the back of this control. This is the input to the volume control. A lot of treble there, right? And then the output from the volume control. Okay, that's coming from my tracer. The speaker's very quiet compared to the tracer. So it looks like there's a load of RF. We should not be able to hear the audio. That's also there. Let's go to the other side of this capacitor. So much signal right around here. Just putting the probe in the areas. That's interesting in itself. So it looks like there's the transformer in here is pumping out quite a field, and the field is trapped in the IF can, but it's coming out the hole. Beyond those wires. I'll bet you it's this wire. I bet you it's this wire coming out to here. That's going to the diodes. Well, that's perfect. That's the output of the transformer going over to the detector diodes. After the detector diodes, well, you actually look on the other side of the transformer. That's down here. That's this wire. So this wire is radiating the IF signal quite strongly, right through the radio. I think maybe they should have put that one down on the chassis. We come into this volume control, and there's a capacitor on it, right there. That guy's that's the 0.0025. Is it? Let's go on one side. Okay, so it's the input side. Hold it steadier. And the output side. Nothing much. Tune my signal tracer a little bit here. Put this on the input to the volume control. 250 kilohertz, 250, 300, 350, 400. You know, what I expect to have happen over here is when you tune in the signal, it's like any radio, it just tunes it in a very small area. Why am I picking it up so broadly through here? Is the audio coming through on this? It's supposed to only be RF. Is the audio coming through? Let's well, that tone I'm hearing, well, it's a modulated RF. Yeah, I would hear it with this. The tone is coming from the signal generator. Well, okay, so it's making it all the way over to this other side of the volume control capacitor. As I bring the pointer close, I'm getting very close to the wire that's coming out of here. So when I think I'm making a test on this terminal, I'm really holding my sensor close to this wire and getting fooled. Well, from there, goes through a resistor. Oh, this is a ground terminal here. Nothing at all. Well, let's keep going. The output of this tube I believe it's right here. There's so much signal just blasting out of there. I can't hear what I want to hear over it. Well, here, other side of this capacitor, this would be the grid. I believe that this is the grid input to the output tube. Still hear it. That's suggesting there's RF right here on the grid of the output tube. Or this thing hears the audio. Can you hear audio with this? I mean, it has an audio setting down here. You switch it to audio. But it's set to RF. Well, I gotta find out. How am I gonna find that out? The answer, my friend, is in my coffee cup. The answer is in my coffee cup. My friend. Okay, so first thing I want to do is prove that my signal tracer does not respond to audio when it's set to RF. So I have this signal generator operating. It's producing a signal around 1300 hertz. Let's hear it. This is a speaker here. Sweep off. Voila. We could take it down a little bit. Okay, there's the signal. Enough to drive the speaker here. What do we hear over here? First I have to ground this. Okay, here we go. I'm tangled up. I hear it. Huh. Yeah. Okay, well, it's a little bit unexpected. So What this means is we can't be sure what we're hearing with the signal tracer when there's both RF and audio. And that's what's potentially happening here. I'm not sure how I can sort that out. Look at it on the scope. I think might be the better way. You can certainly see the RF if it's present. I think that's a good idea. So let me, we'll just make use of this scope here, and we'll sort this out. I'll get things set up here. Maybe get some more coffee in. Wow, something really exciting happened here. And I did not have the camera rolling while I was sitting here. I'm gonna make this happen again. It's probably not the most recommended thing. I'm gonna turn the power back on. So what I've done is I've hooked up a oscilloscope here. The ground I've applied to the ground connection here with the other ground. And while I was doing that, suddenly some sizzling came out of this radio. I'm going to tell you where it's coming from because when I demonstrate this it may not last long. This capacitor right here began sizzling. Okay, I've got the dim bulbs in the circuit here, so if something really bad happens they will come on. Okay, let's give it a try. There we go. Maybe it's going to go poof. Are you ready? Okay, no poofing. See, this is what I mean. When you're busy doing something, fooling around, looking for stuff, something else can show up that's much more interesting. Now, this guy's probably getting really hot. I mean, sizzling? How hot does it get to sizzle? It's not going to sizzle for me. Turn this down. Are you going to sizzle? Or are you going to go bang? Well, judging by what's happening now, no sizzle has started. Whatever's going on in here is going on slowly over a long period of time. This has probably always been acting up. We just haven't had the radio on long enough to detect it, to notice it. Or did I do something? The only thing I did was hook up the scope. You can see the scope there. It's doing its thing. Everything's normal. Okay, let's do this. Rather than do this brutal test, I'm going to go get my thermal imager and we will take a look at that capacitor. Or was something temporarily shorted? Did something short temporarily? That's kind of the same thing said twice. So I have this here. You can also look at what is that capacitor anyway. What's it doing? Now, how do you fry a capacitor? Apply a much higher voltage than it's built for? That's not going to fry it. The capacitor should not get hot. So it has to be leaking. There has to be a leak current. There has to be a fair pressure on it to push the leak current through. Yeah, we should find out what that capacitor is. Let me get let's do the thermal thing first, and we'll see how hot it's. See if it's real, or am I full of crap? So getting the thermal viewer to show up on the camera is tricky business. Let's see what we can do here. As I remember how to turn it on. Okay, now there's lots of settings. Everything's looking red, so we're going to change a few settings here. Raise the red temperature. once again. So now it's becoming only sensitive to the hottest things. Okay, you can kind of see what's going on there. This device, I think a lot of them would do the same thing. It also reports the highest temperature on the screen and the lowest temperature. So the highest temperature it's reporting is 45 degrees. That's in that red spot. And that red spot is probably, yeah, can you see my finger go over it? Let's see if I can get a little better camera view of this. Because one of the things about using these viewers is this one here anyway has a huge wide angle on it, so it's real easy to not to think you're looking at something that you're not actually looking at. Okay, so you see that red spot? I'm going to pass my finger in front of the tube. You can see my finger go by right there. So that's that tube. What about this capacitor? So yeah, there's some heat there. You can see it like this. Other components are hot too. So let's turn this back on. Nothing much over here. And we'll just watch the capacitor. So let me put this like this. So the capacitor's right here in the middle. Here we go. Power on. Bit of a slow motion thing, I imagine. And it has to wait for the high voltage. Okay, here comes the signal. You can see it on the scope. What happened to the view here? Very hard to see. Number of times I've had a capacitor fry. Really, this is it. It was literally making a frying sound. Doesn't seem very exciting at all. So there's a white plus here, right in the center of the screen. Whatever is under that white plus, the temperature is reported there. So I'll move the capacitor under 37. That's nothing. Am I looking at the right thing? There's nothing else that's hot. Tube base. This is it. This is this resistor right here. I wish I could get a better image for you to look at, but I can't really. It's much nicer looking at this with my eye. It's got nice colors, yellow, green, and the like. What happens if I do this? It's probably going to be worse. It's even worse. Yeah, looking at a light. The camera looking at a light. It doesn't work very well. We need more light. More light, not less light. Just bear with me a sec here. More light. More light. Okay, we'll give more light. That's more light. Hey, maybe you can see things a little better. In the meantime, what's happened to that capacitor? It's done nothing. This is odd. This is very odd. It's also, when I first had the problem, I wish the camera had been running. This is why I keep the cameras going almost all the time. That thing was liquid on the top. You could see it. You could see it was melting. Not now. Not now. What happened there? Okay, go back to just thinking about it logically. What can you do to something like that externally to make it overheat? Supply a stupid voltage to it. There's no stupid, like 1,000 volts. There's no such thing in here. It has a leak in it. And I did something to exacerbate the effect of the leak. How would I do that? It was right after I connect the oscilloscope ground. Well, I noticed it right after I connected the oscilloscope ground. And I just can't see how that's going to be responsible for anything. Well, that's a real mystery. That is a big mystery. You guys say it one more time. Look at that, it's just cooled right down. Whatever was happening has stopped. Meanwhile, the radio was operating normally, like it sounded normal. Let's find out what that capacitor is. I'm going to cut the power here. Let's find out what that capacitor is doing, where it's connected. I think I know already. I think it's across. I don't know. It's connected to pin number 1, 2, 3, 4, 5. Pin 5 of the rectifier tube. Pin 5 of the rectifier tube. Okay, let's take a look at the schematic here. Pin 5 of the rectifier tube. 1, 2, 3, 4, 5. It's bound to be this one. This is B. This is B minus here. This is B minus. And this has the full output from the power supply. Huh. Right. Well, I think it had the full B plus across it. 130 volts or something like that. So, and there would be enough power available to cook it while still powering the rest of the radio. So some kind of internal partial short took place in this capacitor. And then that short has cleared itself somehow. Could be a thermal thing. Could be in the long run the short will redevelop and then the short circuit overheats the capacitor. It would have to be like a partial short circuit. I don't know what to think. Well, I think I got to change it out. That's for sure. Yeah, it definitely goes from the B plus to B minus. It's right across the whole shooting match. But you know, it's just darn lucky I happen to be standing here. Let's go back to the radio. Well, since I haven't been able to make the event reoccur, my options are, well, I'll try again, leave it running for a while, turn it on, wiggle the capacitor, see if I can initiate a fault in it. It just, it's right across the B plus. It just doesn't sound like a smart move. Remove the capacitor, test it. Well, if it's in this state, well, surely to goodness this is a leaky capacitor. It's going to show up that way. Okay, power off. Power is off. Cutters in hand. Okay, buddy, you reached the end of the road here. You're coming out. You're coming out. Okay, so one side is going to the ground way over here, or to the B minus rather, and the other one's going to the here. That's where it's going. Okay, am I going to forget? See, I just don't know what's going to happen. Maybe the cats are going to demand that I come outside with them, and then I'll forget. Hey, are you having trouble with the room effect? When I left the shop a few minutes ago, I went to ponder what to do, and I went into my rec room basically. And I got there, I couldn't remember what was it I was going to do. Does this happen to you? It happens to me and my wife all the time. I think it happens to everybody. It's called a room effect. You think of something in one room, and when you go to the other room, you can't remember it. Now, this is a normal function of our memory, as much as it may not seem like a normal function. Yeah, look at the bottom of it. Wow. That was foaming right up. Not hot. Well, let's put it on the tester. We'll see what happens. I can crank the voltage up to the point where I force a failure. Yeah, well, I might be able to force a failure. It's not really the idea, though. The idea is I don't want to bend the leads or do anything, because it changed the conditions of the capacitor. I gotta pull this one off. Okay, any surprise here when I do this test? Any surprises coming? I kind of doubt it. Watch the pi 50. Oh my gosh, it opened right out of the perfectly normal. 150. Oh my gosh, it's opening up. Not all the way. These other capacitors, some of them tested much worse than this one. What could have happened here? Wow. Something internal must have happened to this capacitor, and then it cleared away. Oh my gosh, really? I mean, let's give it another shot here. Now we can't hurt my tester. It's still opening. It's opening ever so, just a little tiny bit, but it's opening. This is 250 volts on it. And if I flex it a bit, and watching the eye for anything to happen. Well, that's a mystery. That's a big mystery. That's kind of a scary mystery. If I hadn't been in the shop here, I could have left the radio on, which I do. Go drink some coffee. This thing's frying away in here like so many, bacon and eggs going on. And what would happen eventually? Well, it's right across the B+. So if it melted down, like if the wax and everything, it's possible it would develop an internal short. You have a short right across the B+. That would, it's not good. I think it would probably destroy the rectifier tube in fairly short order. You might even get an arc inside the rectifier tube. Not sure of that. Well, jeepers. Yeah, jeepers. That's what I would say. What's that capacitor supposed to be doing there? Anyway, you know what? I'm going to go back and look at the schematic some more. What are you doing here? Right on the plate. The top of the heater string. This goes straight to here. Can you get this other side to the other side of that capacitor? Oh my gosh, you can. It's right across the line. Huh. Okay, well, like, why do they show it up here? Why don't they show it here? And I don't know the answer answer to that question. Is there something? Am I not getting something? This is a straight piece of wire right to the plug. This is a straight piece of wire straight to the plug. It's right across the line. Well, we know where the power was coming from. It's spinning turbines at Niagara Falls are driving electrons through that capacitor at a undesirable rate. The test I did with my tester, which I left on here, is a DC test. You know, when I turned the radio back on, the 120 volts was on it again. I don't know. I don't know what to say. I don't think I'm going to get to the bottom of this. I don't think I'm going to get the good feeling of knowing exactly what happened here. It's like an accident investigation. You know, sometimes they end and they don't know what happened. They really don't. Not for sure, anyway. That's the case here. So I'm going to put in a new capacitor to replace this one, which definitely fried. And I will use an X-type safety capacitor. They like to call them safety capacitors. I'm looking for the rating on this. A little hard to read now. Yeah, it's cooked. See the wax melted off the top and collected on the bottom of it. Oop! Hey, it's trying to get back in. Can't let that happen. Okay, I'll stick a replacement capacitor in there. Okay, so I put in this type of capacitor. This is called an X type, sometimes called a safety capacitor. X goes across the line. There's a Y type also, which you would use two of them, I believe anyway, two of them from each of the lines to a common ground point in the middle, something like that. But this one goes right across, so we use the X type. What is so special about them? I really don't know, to be honest with you. I mean, they're not made of wax and paper, so first off. But they have something about them that makes them good to use in this kind of scenario. There it is there. And it's soldered in good. Well, wow. Only something internal could have led to what happened to that other capacitor. It had to be something internal to the capacitor itself. Okay, well, you know, what did I say? You fool around, do this kind of stuff, and you find things you don't expect to find. Look in places no one else is looking. Find stuff nobody else is finding. Okay, so we're going to apply the power. Once again, dim bulbs behave normal. All is good. Now, what we were really trying to do was assess the RF as it continues into the audio circuits of the radio. That's another way of putting what I've been up to. So, there we are. Everything's working again. Never stopped working. Okay. So I have a camera aimed on my scope here. We'll take a look at it. Okay, so it's tipped on an angle. Actually, I was in the midst of de-tipping this camera when the crackle started. So let's go back here. There we are. That's a little better. So you're seeing the audio signal, and you're seeing the RF signal, which is painting this part in here. And where are we connected right now? We are looking at the output from the last IF transformer. There's already a capacitor there trying to, well, where the oscilloscope is connected, we shouldn't see any RF if the capacitor was big enough to do away with all of it. but maybe it's not. Okay, I'm gonna change things a little bit here, camera-wise. Okay, let's carry on with the real experiment. So, disconnect the scope. The black wire runs up to the input of the volume control, and we have the output of the volume control. And then, I really don't. What I'm going to do here is try to not get a shock. Shouldn't get a shock. I'm going to get rid of the tracer around. Now using an extension cord to B minus here, or a clip lead to B minus. Okay. I'm going to use a different clip lead here. Ooh, don't drop that. It's loose in here. Okay, that's not the best thing, but I think we can carry on. I know what it is. Okay, now I'm going to go and look and see what appears on the other side of the audio capacitor here. What was that? Momentarily did something. Anything cooking? No. Don't do that. Ooh, son of a gun. What's happening there? What's going on? Oh my God, what is happening? The particular terminal I connected to is not hooked up to a tube pin. There's no tube pin in that tube for that particular terminal. What's going on? Who's shorting to who? I just don't see any. I don't see any cause. I don't see. Okay, what's on the scope? We'll just hold it here in the air. What's on the scope? And I haven't even looked at it. Not much. Let's make it a little more sensitive. You see the audio signal. Maybe I can get this to stop doing its thing there. Maybe not. A little hard to trigger on a signal that looks like that. Oh, son of a gun. What the heck is going on? I don't like the situation. I do not like it. I'm going to cut the power here. Just out of the corner of my eye, I saw the speaker cone travel a fair bit during one of those. Well, how can you get the speaker cone to travel and sit? How can that happen? Only if you shove DC through the transformer or through the speaker. How can that happen? The speaker has its own transformer up here. You know, one way it could happen is a false observation. It was the corner of my eye sort of thing. The other day I was walking through my house, and just out of the corner of my eye I saw my cat Peanut just on the ground where he often is, just sitting, laying on the floor like a cat does. And a couple minutes later I was walking back the other way, and it wasn't my cat, it was just a bag. Now here's the thing, when I saw my cat, I didn't see a bag that looked like a cat. And I didn't see my cat Peanut looking a little like a bag. I saw my cat. I saw his tail, his head, I saw everything when I went by the first time. It's a false vision. And this is what our powerful brains are doing for us all the time. And once in a while it messes up like that. And you think you're seeing something that you're not. In a very, very convincing way. Well, I don't know what to think. I think this. I think it's late enough. I'm going to stop now. Something going on here. Clip leads causing some kind of short. I just can't see how. Maybe the tube pins loose in the socket. Moving around a little bit, break a connection. The deep hum scared me a little bit. Because it sounded like a 60 cycle hum. Saw the speaker kind of jump. I don't know, it's all too much. It's too much. So that's it for today. We're going to leave it right there. I did manage to change one capacitor. Had an exciting moment today with the frying of a capacitor. That's great. So thanks a lot for watching, and tomorrow I'll carry on, and hopefully I won't turn this radio into a basket case. It will end up working in the long run. Thanks a lot for watching. I hope you're getting a kick out of this. You know, this is all about having fun and the like. This isn't a serious business here. This is a pastime. So thanks a lot for watching, and see you on the next video.